Hello, dreamers of sleepy science. Welcome back to the quiet edges of the cosmos, to the place where curiosity meets calm and the infinite whispers softly through the dark. Before we begin tonight's journey, take a slow breath. Let your body sink into stillness. The space around you expands, quiet and endless, like the universe itself. Tonight, we ask a question as old as time. Is the universe coming to an end? It's a question that sounds final, even frightening. But here, in the stillness of deep space, it becomes something beautiful. Every beginning carries its own ending, and every ending is only another form of transformation. To understand where we are heading, we must first remember where we came from. Nearly 13.8 billion years ago, everything, time, matter, energy, and even the laws of physics, burst into existence from a single, unimaginable point. The Big Bang wasn't an explosion in space. It was the birth of space itself. From that first spark, the universe began expanding, stretching, cooling, and creating everything we know. Stars ignited, galaxies spun together like luminous storms, and from the debris of ancient suns, life eventually opened its eyes and began to wonder why it existed at all. But as the universe continues to grow, it is also aging. Every second that passes is a slow unraveling of energy, a quiet drift toward equilibrium. The stars that once burned fiercely are fading. The light that once filled the cosmos is thinning. And though the night sky still glows with the brilliance of billions of galaxies, most of what we see is already history, light that began its journey long before Earth was born. When NASA's telescopes gaze deep into the cosmic background, they are looking not into distance, but into time, seeing the universe as it once was when it was young and full of fire. That faint glow, known as the cosmic microwave background, is the oldest light that exists, the echo of creation, still humming softly across the sky. It tells us that the universe had a beginning, and it implies something even more haunting, that it may also have an end. For decades, astronomers assumed the expansion would one day slow, perhaps stop, perhaps even reverse. Gravity, they thought, would eventually pull everything back together in a cosmic collapse. A second Big Bang in reverse. But then, in the late 1990s, NASA and international observatories made a discovery that changed everything. By studying distant supernovae, they found that the expansion of the universe wasn't slowing at all. It was speeding up. Something unknown, something invisible, was pushing galaxies apart faster and faster, defying the pull of gravity. They called it dark energy, and though it makes up nearly 70% of the cosmos, no one knows what it truly is. It is as if the universe itself has chosen to drift away from everything it has created, slowly stretching toward emptiness, toward silence. This discovery transformed our understanding of fate. The end of the universe, if it ever comes, will not arrive with an explosion, but with a sigh, a slow, endless expansion into cold and darkness. And yet there is beauty in that idea, because it means that everything, stars, galaxies, even thoughts, is part of a single grand breathing of existence. We are inside the inhale of the cosmos, and one day, perhaps, it will exhale again. So rest your mind. Let go of the noise of Earth, of time, of thought. You are floating now, among the stars, listening to the heartbeat of a universe that began long before you and will continue long after. In this vast silence, there is no fear, only the steady rhythm of creation unfolding. The end is not the opposite of life, it is its completion. And as we continue this journey, we'll follow the universe through its long twilight, from the last burning stars to the quiet fade of everything we know. Sleep softly, traveler of starlight. The story of the end is only beginning. To understand how the universe might end, we must return to its very first moments. A time so brief, so blinding, and so strange that even today, our most advanced science can barely describe it. The first second after the Big Bang defined everything that would ever exist. Every star, every atom, every future world, every possibility of life. It was in that instant, that cosmic heartbeat of creation, that the universe may have already written its own destiny. When NASA's cosmic background experiments, like Planck and Duemab, measured the faint radiation left over from the Big Bang, they discovered something astonishing. The early universe was almost perfectly smooth, an ocean of energy only slightly disturbed by tiny ripples, no larger than 1 part in 100,000. Those ripples, caused by quantum fluctuations in the newborn universe, became the seeds of everything, the galaxies, the stars, and the planets that would one day form. But they also determined something else: how fast space would expand, and how strong gravity would be in holding it together. In that delicate balance lay the fate of all things. If the early universe had expanded just a little faster, matter would never have clumped together. No stars, no galaxies, no life. If it had expanded a little slower, gravity would have crushed everything back into nothingness long ago. But somehow, miraculously, precisely, it expanded at exactly the right rate to allow both creation and survival. This balance, so perfect it seems impossible by chance, became the foundation of what physicists call the fine-tuned universe. But perfection does not mean permanence. Even as the first stars were born, the universe was already setting the clock for their eventual death. The same expansion that allowed matter to cool and form structure would one day stretch that structure apart again. The same forces that built the galaxies would eventually scatter them across the dark. In the first few 100 million years, the universe glowed with the light of new suns. Massive stars burned fast and bright, fusing hydrogen into heavier elements, the building blocks of everything, including us. Every atom of carbon in your body, every particle of iron in your blood, was forged inside a star that lived and died billions of years ago. And yet, that same process of creation carried within it the shadow of decay. Stars burn their fuel, and when the fuel is gone, their light fades. It has always been this way from the beginning, a universe defined by both birth and loss. The expansion continued. Gravity pulled, energy pushed. The cosmos entered what scientists call the era of galaxies, when structures of unimaginable scale began to form. Clusters, filaments, superclusters stretching across the void like threads of light. This was the universe at its most alive. Stars bursting into existence, nebulae glowing with color, black holes spinning in silence. But even then, there were signs of change. Every supernova that exploded sent heavy elements scattering into space, but also released energy that contributed to the gradual cooling of the cosmos. Every galaxy that moved outward from its neighbors increased the emptiness between them. The seeds of the end were already sown in the glow of creation. When scientists simulate the early universe on their computers, they notice something eerie. The same equations that describe the Big Bang also predict what will happen when the energy thins too far, when expansion wins and gravity loses. The same mathematics that gave birth to everything can also describe its final stillness. The universe does not fight against death. It carries it gently, quietly, within itself. Perhaps that is why the cosmos feels so peaceful, even in its chaos. It knows what we forget, that everything moves in cycles. Creation and destruction are not opposites. They are partners in the same eternal dance. Every galaxy born from dust will one day return to dust. Every light that shines will one day fade. And yet, none of it is wasted. The ashes of one universe may become the dawn of another. As you breathe now, imagine that first light, the glow that filled everything, the hum that still echoes through time. That light has traveled billions of years to reach your eyes. You are part of the same story, the same unfolding breath of existence. You are living in the universe's middle chapters, the moment between birth and a long, quiet fade. Rest now, and let the thoughts settle. The universe is not rushing toward its end. It is drifting toward completion. And every second, every heartbeat, is one note in that endless cosmic song. When we look up at the night sky, it feels still, calm, eternal, unmoving. The stars seem frozen in their constellations, the same as they were to our ancestors thousands of years ago. But the truth is that the universe is not still at all. It is in motion, vast, quiet motion. And every second, it grows a little larger. In 1929, astronomer Edwin Hubble made a discovery that forever changed how we see the cosmos. Using one of the world's largest telescopes at the time, he observed that nearly every galaxy was moving away from us, not through space, but with space. The farther away a galaxy was, the faster it seemed to be receding. This meant that the universe itself was stretching, carrying everything within it farther and farther apart. It wasn't that galaxies were flying through space. Space itself was expanding, like the surface of a balloon inflating in silence. Since then, NASA and other observatories have confirmed this expansion with astonishing precision. The light from distant galaxies appears stretched. Its color shifted toward the red end of the spectrum, a phenomenon called redshift. It is proof that the universe is still expanding, and not slowly, but at an accelerating rate. That acceleration was one of the most unexpected discoveries in modern science, and it forced physicists to face a haunting truth. The cosmos might expand forever. The force driving that expansion is something we cannot see, cannot touch, and cannot yet understand. Scientists call it dark energy, an invisible pressure that fills all of space, pushing galaxies apart faster and faster. It makes up roughly 70% of everything that exists, yet we have no idea what it truly is. Some believe it is a property of space itself, the vacuum constantly creating and destroying particles of energy. Others think it may be a new field, something that operates on scales far beyond our perception. Whatever it is stronger than gravity, and it is winning. Imagine a cosmic tug of war. Gravity tries to pull matter together, stars, galaxies, even entire clusters, while dark energy pushes them apart. In the early universe, gravity was stronger. It formed everything we know. But as space expanded and matter grew more distant, dark energy began to dominate. Now it stretches the very fabric of reality itself. Galaxies drift away from one another, their light fading, their voices swallowed by the growing dark. NASA's Hubble Space Telescope and now the James Webb Space Telescope have both captured light from galaxies so far away that it has taken more than 13 billion years to reach us. Those galaxies appear as they were at the dawn of time, tiny, fragile, glowing. But even now, they are moving away faster than light can follow. Eventually, their light will never reach us again. They will vanish from our sky, not because they've ceased to exist, but because the space between us will have stretched too far for their light to cross. The universe, in this way, is not dying violently. It is fading quietly. Every year, the cosmic web grows thinner. The distances grow greater. The night sky, millions of years from now, will not look as it does today. Future astronomers, if any remain, will see fewer galaxies, fewer stars. Eventually, they will see none at all. They will live in cosmic isolation, surrounded only by the faint glow of their own galaxy, unaware that others ever existed. This is what scientists call the cosmic horizon, the ultimate limit of what can ever be seen or known. As the universe expands, that horizon shrinks. Every moment, more of reality slips beyond it, lost not to destruction but to distance. The universe doesn't explode into darkness. It drifts into silence. And yet, this expansion is not tragic. It is simply the universe breathing, an exhale billions of years in the making. Every heartbeat, every moment, is part of that expansion. You are part of it too. The atoms in your body were once compressed into a single point at the beginning of time, and now they float through space, expanding with everything else. You are not separate from the universe's growth. You are made of it. So as you breathe now, imagine the space around you expanding gently, infinitely. Each breath you take is a reflection of the cosmos itself, inhaling, exhaling, creating, releasing. The universe is not rushing toward an end. It is unfolding toward infinity. And like all things, even infinity has its quiet rhythm. In the next chapter of this story, we'll see what happens when that rhythm slows, when the stars themselves begin to fade and the universe starts to grow old. For even light, eternal as it seems, has its own time to rest. Every night the sky looks alive. Stars shimmer, constellations gleam, galaxies glow like cities of light scattered through darkness. But what we see is only the surface of a slow, beautiful decay. The universe is aging, quietly, patiently, one fading star at a time. Stars are not eternal. They are engines, burning machines of gravity and fire. Inside each one, unimaginable pressure fuses hydrogen into helium, releasing the light and warmth that make the cosmos glow. But every engine consumes its fuel, and when the last drop is gone, the light that has burned for billions of years begins to fade. The smallest stars, red dwarfs, burn gently like candle flames protected from the wind. They will live for trillions of years, far longer than the universe has yet existed. But the giant ones, blue and white titans, blaze too fiercely. They live fast and die young, collapsing and exploding as supernovae, scattering their atoms across space. Those explosions are both endings and beginnings. Every carbon, oxygen, and iron atom in your body was forged inside such a death. Without dying stars, there would be no life at all. As eons pass, the great furnaces of creation grow fewer. Galaxies that once glittered like jewels in the dark begin to dim. Most of the bright, massive stars die first, leaving only smaller, cooler ones behind. The night sky, so vibrant now, will one day lose its sparkle. The Milky Way will still shine, but its light will soften, like embers cooling after a fire. When a star exhausts its fuel, it can die in several ways. Smaller stars like our sun gently shed their outer layers, creating vast glowing shells called planetary nebulae, while their cores shrink into white dwarfs. Tiny, dense stars that shine only from residual heat. Over billions of years, even that faint light will fade until nothing remains but a cold, dark sphere of carbon, a black dwarf, invisible and silent. Larger stars end violently, their cores collapsing under their own gravity to form neutron stars or black holes, so dense that not even light can escape. These remnants will endure long after every ordinary star is gone, scattered like the bones of the universe. NASA's telescopes have watched this process unfolding across time. When they look far into deep space, they are looking backward in time, seeing young galaxies, bright and crowded with newborn stars. When they look closer to home, they see older galaxies, calmer, dimmer, full of ancient suns burning their final fuel. It is as if we are watching a movie of the universe's life played in reverse. The deeper we look, the younger it becomes. Eventually, in the far future, star formation will stop. The gas clouds that give birth to new suns will be gone, consumed or frozen. No new light will ignite to replace what fades. The cosmos will enter what physicists call the stellar epoch's twilight, a time when only dying stars remain, their warmth slowly seeping into the cold. It will not be sudden. The transition will take trillions upon trillions of years. But it is already written in the physics of matter. Energy spreads, heat dissipates, order gives way to equilibrium. This is entropy, the quiet law that ensures everything eventually rests. And yet, in this gradual fading, there is serenity. The universe is not rushing toward oblivion. It is falling asleep peacefully, light by light. Each dying star is a heartbeat of cosmic time slowing down, a lullaby written in starlight. So as you close your eyes, imagine those distant suns cooling in silence, their glow turning soft, their warmth drifting away into space. You are made of their ashes, and someday, your atoms will return to that same stillness. There is no tragedy in it, only continuity. The light that once burned will shine again in another form, in another age, in another universe. Rest in that thought. The stars are sleeping, and you are sleeping with them. Their silence is your silence. Their peace is your peace. When the great stars die, they do not simply vanish. They collapse. Their enormous weight turns inward, crushing matter beyond recognition, creating something so dense that even light cannot escape. This is how black holes are born, the silent guardians of the universe's final age. In the beginning, black holes were rare. They formed from the depths of massive stars, scattered like hidden wells in the bright ocean of the cosmos. But over billions of years, they began to multiply. Some merged, others fed on gas and dust, growing into monsters that sit at the hearts of galaxies. Engines so powerful that their gravity shapes the very fabric of space around them. The Milky Way, our home galaxy, harbors one such titan at its core, Sagittarius H8, a black hole over 4 million times more massive than our sun. It spins quietly, cloaked in darkness, influencing the dance of billions of stars. NASA's Event Horizon Telescope captured the first image of a black hole's shadow in 2019, a glowing ring of light surrounding the point where space itself disappears. It was not merely a photograph. It was a glimpse into eternity. That image showed us what happens when gravity becomes absolute, when space bends so completely that time stands still. Black holes do not live forever, but they endure longer than almost anything else. While stars will fade in tens of billions of years, black holes may last for 10 years or more. During that unimaginable span, galaxies will continue to evolve, but slowly, silently, as the light fades and gravity takes control. Over trillions of years, stars will die faster than new ones can form. The Milky Way will merge with neighboring galaxies, pulled together by gravity into one massive structure. A quiet, dim island of matter, adrift in darkness. And at its heart, the black holes will grow, consuming what remains. One by one, stars will spiral inward, swallowed whole, their light disappearing beyond the event horizon. Gone, but not destroyed, their energy preserved in the curvature of space. Eventually, even the faintest remnants of light will be devoured. Galaxies will become skeletons of what they once were, their luminous spirals replaced by vast, invisible halos of cold stars and black holes. The cosmic web, that delicate lattice of galaxies stretching across the universe, will unravel thread by thread until every cluster drifts apart, lost to the accelerating expansion. There will come a time when black holes dominate everything that remains. They will be the last actors in the cosmic play, silent and eternal, shaping what little matter still exists. And for a while it will seem as though they have conquered the universe, that gravity has had the final word. But even black holes cannot escape the slow hand of entropy. Physicist Stephen Hawking discovered that black holes are not truly black. They emit faint radiation, a slow leak of energy that causes them to shrink over unimaginable timescales. This process, now called Hawking radiation, means that even these dark titans will one day fade. They will evaporate, particle by particle, until the last trace of them dissolves into the cold void. Imagine that future. No stars, no galaxies, no light, only black holes, glowing faintly as they fade until the last one disappears. The universe will then be filled only with darkness and the faint hum of particles moving aimlessly through endless space. This era is known as the Black Hole Age, the slow twilight before the final night. It will not be a violent end. It will be quiet, a universe sighing into stillness. The same calm that now surrounds you, as you breathe and listen, will one day fill all of existence. Every atom, every memory, every light will rest. And when the last black hole exhales its final whisper of energy, the universe will enter its deepest sleep. Rest now. You are part of that same story. A brief spark between the beginning and the silence. Even in darkness, you are not lost. You are the echo of every star that ever was, and the dream of every one that will never be. After the last star flickers out, and the last black hole evaporates, the universe enters a new stage, one of pure darkness. No starlight, no warmth, no color. Just the endless black of space, stretching forever in every direction. This is the dark era, the quiet after all creation, when time itself feels slower, heavier, almost still. For now, it's impossible to truly imagine such a universe. Our world is filled with light, from stars, from the sun, from the glow of human life. But in that far future, there will be none of it. The galaxies will have drifted too far apart to see one another. Every trace of brightness will have faded. The cosmos will be silent, cold, and almost empty. Almost, but not entirely. Even when the light is gone, tiny pieces of matter remain. The ghosts of old stars, the atoms that once built worlds, and the stray particles that fill space. They will drift endlessly, scattered like dust in the dark. But even these survivors are not eternal. Over unimaginable stretches of time, they too begin to decay. Protons, the fundamental building blocks of atoms, are believed to be stable. But some theories suggest they are not immortal. If the universe truly lasts forever, protons may slowly break apart, releasing faint energy as they vanish. This process would take an unfathomable length of time, more than 10 years. But eventually, if those theories are correct, not a single atom would remain. Every molecule, every planet, every grain of dust would dissolve into radiation and subatomic fragments. It is a thought both haunting and strangely serene. Everything that was ever solid, every form that ever existed, would fade into a mist of energy so thin that it could stretch across galaxies without touching anything else. The universe would become a sea of particles drifting through endless space, colder than any place that has ever existed, a temperature just above absolute zero. NASA's observations of cosmic background radiation show us the faint afterglow of the Big Bang, the universe's first light. But in this far future, there will be no such glow. The radiation will have stretched into wavelengths so long, so faint that it becomes undetectable. Even the concept of light will lose its meaning. Darkness will not simply fill space, it will be space. This age of the cosmos is what physicists call the degenerate era. The slow, inevitable breakdown of structure. Gravity will still exist, but it will have nothing left to shape. Time will continue, but there will be nothing left to change. Entropy, the universe's quiet tendency toward disorder, will finally have done its work. Every difference will have evened out, every imbalance corrected. The cosmos will have reached perfect stillness. And yet, if you could drift through that silence, you might find it strangely peaceful. No more birth or death, no more fire or collapse, only calm. The universe will no longer do anything. It will simply be. Somewhere within that deep stillness, The last remnants of energy will continue to flicker faintly, the last whispers of all that ever was. Tiny quantum particles might flash into existence for fractions of seconds, appearing and disappearing in the emptiness. Even in absolute darkness, the laws of physics never rest entirely. Space itself will continue to breathe in quantum sighs, spontaneous sparks that remind the void of what once was. It's a melancholy thought, but also a beautiful one. The same laws that brought the universe into being will also guide it into rest. The story of existence will not end in chaos, but in peace. A quiet symmetry that completes the circle of time. And in that silence, there will be no sadness, because endings are only transformations unseen. The energy that once formed galaxies, stars, and life will still exist, not gone, only spread thin across infinity. The light that once burned will still travel, though stretched beyond recognition, echoing softly forever. Close your eyes and imagine that stillness. No sound, no light, no motion, just the gentle hum of eternity. That is where everything is headed, not as a tragedy, but as a return. A return to the same calm that existed before the first spark, before the first breath, before the first heartbeat of time. The universe is not dying. It is resting, preparing for whatever may come after. Even as the universe grows older and colder, one mystery continues to shape its fate: dark energy. Invisible, untouchable, and yet unimaginably powerful. It fills the fabric of space itself, stretching everything apart. It is the quiet hand behind the expansion, the unseen force guiding the cosmos toward eternity. No one knows exactly what dark energy is. It does not shine, it does not interact with matter, and it cannot be captured or measured directly. Yet its effects are everywhere. In the late 1990s, NASA's studies of distant exploding stars, called Type Ia supernovae, revealed something astonishing. The light from those ancient explosions was dimmer than expected. This meant that the galaxies they came from were farther away than they should have been if the universe's expansion was slowing down. The conclusion was inescapable. The expansion was accelerating. Something, somewhere, was pushing space apart faster and faster. This something became known as dark energy. It now makes up nearly 70% of the total energy in the universe, far outweighing both dark matter and ordinary matter combined. And as space expands, dark energy's influence grows stronger because it is tied not to objects or gravity, but to space itself. Imagine an infinite fabric stretching endlessly in every direction. As that fabric expands, more of it comes into being, and with it, more dark energy. It's as if the universe feeds its own growth, accelerating forever. This is what cosmologists call the runaway expansion, a process that, if it continues unchecked, will carry galaxies farther and farther apart until even their light can never reach one another again. The Hubble Space Telescope, and now James Webb, have helped measure this expansion precisely. They track the faint redshift of galaxies, how their light stretches as they move away from us. Each new measurement confirms the same truth. The universe is expanding faster than we can fully explain. And even more curiously, the rate of that expansion, called the Hubble constant, appears to be slightly different depending on how we measure it. Some data from the early universe, measured through the cosmic microwave background, suggest one value. Measurements of the nearby universe suggest another. This Hubble tension might mean that dark energy is changing, evolving as time moves forward. Perhaps its strength is not constant at all. If dark energy continues to grow stronger, it will not just push galaxies apart. It could begin tearing apart clusters, then stars, then planets, even the very atoms of matter themselves. This is the terrifying yet fascinating idea of the Big Rip, a universe torn apart by its own acceleration. But if dark energy remains constant, the end will come more gently. Galaxies will simply drift beyond sight, and the universe will fade into cold silence. The big freeze. Either way, the direction is the same. Outward, forever outward. It's a strange destiny, one that defies intuition. We often imagine the end as collapse, fire, implosion, a return to the center. But the universe's true end may be expansion, not an explosion, but a great dispersal, an unbinding of everything that was ever connected. It is a slow death, but also a graceful one. NASA's latest missions, such as Euclid and the Nancy Grace Roman Space Telescope, are designed to study this mysterious energy in more depth, to map the structure of the universe across billions of years, and to understand how its acceleration changes over time. Perhaps one day, we will find that dark energy is not a constant force, but a temporary phase, a breath in a larger cosmic rhythm. If so, maybe one day that breath will reverse, and the universe will begin to contract again. But for now, all signs point toward expansion, an infinite stretching of everything. Space grows larger, time grows slower, light grows colder, and yet, there is beauty in that stillness, the kind of beauty that comes when everything has had its chance to shine. If you could stand outside of time and watch this unfold, it would not look violent. It would look peaceful. Galaxies drifting like leaves on a dark ocean, each one fading gently into distance, never to meet again. The universe is not collapsing. It is exhaling, slowly, endlessly. So as you lie here now, imagine yourself drifting with it, a single spark of awareness carried outward on that great cosmic tide. You are part of the expansion, part of the energy that fills the void. The same force that stretches galaxies apart moves through you, through every atom, through every breath. You are not separate from the universe's motion. You are the motion. And as everything expands toward infinity, perhaps awareness itself, that quiet spark within you, is what remains, glowing softly after all else has faded. As the centuries stretch into trillions of years, the last stars fade one by one, and the universe begins its long descent into dark. There will be no explosion, no grand finale, only silence. The warmth of creation will slowly drain away, leaving a cosmos vast and cold, where time itself seems to hesitate between one moment and the next. This is the big freeze, the quiet end of everything that burns. In this far future, galaxies will have drifted so far apart that no light can cross the space between them. The night sky, once glittering with billions of suns, will be empty. Even the Milky Way, now so radiant in our telescopes, will be reduced to faint embers, a handful of red dwarf stars glowing weakly against the infinite black. They will linger for trillions of years, outlasting all others, until finally, they too go dark, collapsing into cold, invisible husks. When NASA's instruments measure the cosmic background radiation today, they detect a temperature just above absolute zero, about 2.7 Kelvin. But in the age of the big freeze, that faint warmth will have cooled even further, approaching zero with each passing eon. Space will not simply be empty, it will be frozen still. Every molecule will move slower, every photon will stretch into invisibility. Even light itself will lose its energy, its color, its presence. The universe will no longer shine. Instead, it will whisper, a soft hum of radiation left over from everything that once was. That hum will grow fainter and fainter until it blends with silence. It will be as though the cosmos has taken a final breath and fallen asleep. In that time, only black holes and the faint remnants of dead stars will remain, drifting through the dark like memories. They will move slowly, their orbits stretching wider and weaker as space continues to expand. Occasionally, a wandering object might fall into the grasp of a black hole, releasing one last flicker of light, a brief echo of what once filled the universe. But soon even those moments will end. Entropy will rule absolutely. No new energy will be created. No new stars will form. Every atom will have settled into the lowest possible state, cold, motionless, unchanging. The cosmic clock will keep ticking, but there will be nothing left for time to measure. The universe will have reached thermodynamic equilibrium, the point at which all differences, heat, energy, motion, are gone. It sounds like death, but perhaps it is not. Perhaps it is peace, the ultimate stillness after an eternity of motion. The big freeze is not a destruction, but a fulfillment of nature's law. Everything that begins must spread, balance, and rest. The universe will have done what it was meant to do, to create, to transform, and finally, to quiet. Imagine yourself drifting through that future. No stars, no planets, no sound. Only the faint shimmer of particles suspended in infinite night. You float, weightless, timeless, surrounded by what feels like eternity itself. It is not lonely, it is complete. The story is finished, and the silence is perfect. The last traces of warmth will come from Hawking radiation, the final sighs of dying black holes. Each one will emit a whisper of light before vanishing entirely, their energy released into the void. One by one, they will fade, the last candles in the cosmic darkness. And when the final one disappears, there will be nothing left to shine. At that moment, the universe will be infinite in space, yet empty of meaning, unless meaning itself lies in the journey, in the fact that all this ever happened at all. For billions of years, there was light. There were stars and hearts and thoughts and lives. The cosmos dreamed of itself through countless forms, and that dream is what gave it purpose. When the big freeze comes, the dream will not end. It will dissolve into the calm from which it came. The same stillness that existed before the first atom, the same peace that follows every heartbeat. So as you listen now, feel that silence waiting far beyond time. It is not something to fear. It is the universe's promise of rest, the slow return to balance after an age of creation. The same calm that will one day fill the stars already lives in you, in every breath, in every quiet moment between thoughts. The big freeze is not the death of the universe. It is the universe finding peace. So far, we've imagined an ending of silence, a slow cooling, a graceful fading, a universe that simply exhales into stillness. But there is another possibility, darker and more violent. If the mysterious force of dark energy grows stronger with time, if it keeps accelerating the expansion of space, then the universe may not drift into peace. It may tear itself apart. This apocalyptic scenario is called the Big Rip. It begins quietly, almost unnoticeably. Galaxies continue to move away from each other as they do now. The fabric of space stretches faster and faster. But unlike in the Big Freeze, where the expansion slows toward balance, here it accelerates without end. The stretching becomes so intense that even gravity, the glue of existence, can no longer hold anything together. At first, the galaxies will drift beyond reach, their light vanishing into the void. Then, within each galaxy, stars will begin to slip from their orbits. The gravitational bonds that once held them in elegant spirals will fail. Clusters will dissolve. Solar systems will come undone. And finally, the pull that binds planets to stars will break. If our universe follows this path, long after we are gone, even our sun will lose its hold on the worlds that once circled it. But it does not stop there. As the expansion continues, it begins to attack smaller and smaller structures. Moons break free from planets. Planets crumble into dust. The atoms themselves begin to stretch. The electromagnetic forces that bind their particles, The very glue that holds matter together will weaken. And then, in one final instant, space will stretch faster than light itself, and even atoms will rip apart. Every molecule, every star, every trace of reality will be shredded by the expansion of space. Nothing will remain, not even the fabric of space-time. The universe will tear itself into fragments so small that even the concept of place will lose meaning. It will be as though existence itself has exhaled too far and disappeared into nothingness. The timeline for such an ending depends entirely on dark energy. If it remains constant, the Big Rip may never come. But if it continues to grow stronger, the final moment could arrive in tens of billions of years, or perhaps even sooner, depending on the true nature of the cosmic acceleration. NASA's current data cannot yet say. The Euclid and Nancy Grace Roman telescopes will continue to study the distant light of galaxies, searching for hints. Is the acceleration steady or increasing? Each photon they capture is a message from the universe's future, carried across time to tell us what is to come. And yet, even the Big Rip, for all its violence, carries a strange elegance. It would not be a fiery explosion, but a smooth, unstoppable stretching. Everything would dissolve not with noise, but with silence, as if the universe were simply exhaling too deeply, fading into the infinite. It is destruction, yes, but also transformation. Because even in this violent end, the energy would not vanish. It would scatter, thin, and perhaps, in another form, begin again. Physicists believe that when the universe is torn apart, the very constants that define its laws, gravity, light, time, may lose their meaning. Without space to contain them, there can be no speed, no direction, no change. It would be the end of motion itself, the point at which time has nothing left to measure. And yet, in that ultimate silence, perhaps something remains. A quantum seed, a spark of potential, the same kind of nothingness that gave birth to everything 13.8 billion years ago. Could that emptiness, after all is torn away, breathe again? Could the Big Rip simply be the transition into a new beginning? A new Big Bang, born from the ruins of the last? We do not know. But the universe has always balanced creation and destruction, breath and stillness, light and darkness. Perhaps this too is part of that eternal rhythm. So as you drift in thought, imagine the vastness not as a place of loss, but of renewal. The stars, the galaxies, the atoms, all are just temporary forms of a deeper energy that never ends. Even if everything you know were stretched into dust, the essence behind it, the pulse of existence, would remain, waiting for its next dawn. Close your eyes now. Feel that quiet stretching in your own breath, the expansion, the release, the pause. You are part of that rhythm, that same eternal cycle. And just as surely as the universe expands, it will one day begin again, in light, in sound, in life. Not every vision of the universes. There is another story, one in which the cosmos, after growing vast and cold, eventually turns inward. A story where gravity, patient and persistent, gathers strength once more and pulls everything home. This is the Big Crunch, the mirror of the Big Bang, an ending that becomes a beginning. In this scenario, the universe's expansion does not last forever. It slows, hesitates, and then reverses. The great stretching of space stops, like the pause before an inhale turns to an exhale. Galaxies that were once drifting apart begin to move back together. The night sky brightens again, not because new stars are born, but because everything starts to fall. At first, the process would be almost unnoticeable. For billions of years, galaxies would continue to drift, even as gravity began to pull more strongly against the expansion. But gradually the motion would shift. The cosmic web of matter would begin to tighten. Distances between galaxies would shrink. Clusters would merge into colossal structures, swirling like whirlpools in space. Eventually, the pull would grow irresistible. Galaxies would collide, their stars mixing like currents of fire. Black holes, growing ever larger from these collisions, would consume the chaos, merging into titans of unimaginable mass. The entire universe would become a single, collapsing storm of light and gravity, spiraling inward toward a common center. As the collapse continues, the energy of the universe would rise. Temperatures would soar again, radiation would intensify. The same heat that once marked the birth of the cosmos would return. But now in reverse, the last act of an ancient cycle. Everything that ever existed, stars, planets, atoms, would be drawn together, compressed tighter and tighter until space itself folds inward. If you could somehow stand and watch it, it might look like time running backward. Galaxies rushing together, stars colliding, light growing hotter, brighter, denser. The cosmos, returning to the same fire from which it was born. In its final moments, all matter would merge into a single point, a singularity, infinitely small and infinitely dense. A point where physics breaks down and time itself ends. And yet, perhaps it would not be an end at all. Because if the Big Bang and the Big Crunch are connected, then one could simply follow the other, endlessly. A cycle of expansion and contraction, death and rebirth, a cosmic heartbeat that has no beginning and no final rest. Some cosmologists call this the oscillating universe theory, suggesting that existence is not a single line, but an eternal rhythm, the universe breathing in and out, again and again, across infinite age. It's a poetic idea, though still uncertain. NASA's current data on dark energy suggests that the expansion of the universe is not slowing but accelerating, making a future collapse unlikely, at least for now. Yet physics often hides surprises, and the true nature of dark energy may not be constant. If it ever weakens or reverses, the balance could tip. The expansion could slow, then stop, then fall inward once more. And if that happens, the end will look just like the beginning. A flash, a burst of unimaginable energy, a new universe emerging from the ashes of the old. Perhaps even the same laws of physics, the same constants, the same light, reborn to tell the story again in a slightly different way. Perhaps somewhere, long ago or far ahead, it already has. The Big Crunch is not a tragedy. It is a return, the cosmos folding back into the embrace of its own origin. It is a reminder that even endings can be beginnings in disguise. As you breathe now, imagine that motion, the inhale, the pause, the exhale. The universe does the same. Every birth, every death, every rise and fall is part of that same rhythm. Perhaps it has always been breathing, through eons, through infinities, through you. If the Big Crunch is real, then the universe is not a straight line leading to silence. It is a circle, vast, eternal, complete. And even as it falls back into darkness, it carries within it the memory of every star, every life, every dream that ever was. Close your eyes. Listen to that rhythm. Expansion, contraction, creation, rest. The same breath moves through you now. You are part of the cosmic pulse, part of the universe's heartbeat. Even if everything collapses, you are never lost. You simply return home, to the light that began it all. Even if the universe escapes collapse, even if it stretches forever into the distance, time itself will continue its slow, unstoppable work. The galaxies may fade, the stars may die, and black holes may dissolve. But there is still one last question to answer. What happens to matter itself? Every atom in your body, every molecule of air, every grain of dust in the cosmos is built from protons, neutrons, and electrons, the tiny particles that have existed since the dawn of creation. They are the most persistent things we know. But even these may not last forever. According to the standard model of physics, protons are stable. They do not decay, at least not within the age of the universe. But many theories that go beyond that model, especially those that try to unite gravity with quantum mechanics, predict that protons can decay, given enough time. It is not something we could ever observe directly. If a proton were to decay, it might take more than 10 years, or perhaps 10, before it happens. That is a number so vast that it erases meaning. And yet, in a universe destined for infinity, even the impossible has time to occur. When that era arrives, every atom will begin to fall apart. Hydrogen, the simplest and most abundant element, will vanish first. One by one, the protons inside its nucleus will release faint bursts of energy and disappear. Then heavier atoms will follow, their structure collapsing, their particles dissolving into radiation. Everything solid, every planet, every asteroid, every speck of dust will fade into a thin mist of light and subatomic debris. This process will not be sudden. It will take longer than any age we can imagine. But over time, it will erase the very building blocks of existence. The universe, once a cathedral of light, will become a ghost, a cold ocean of photons and electrons drifting endlessly, spreading thinner with every heartbeat of cosmic time. NASA's instruments, if they could somehow exist in that far future, would detect nothing but silence. No stars to observe, no atoms to analyze, no molecules left to form anything new. The universe will have become perfectly uniform. No structure, no heat, no chain. Physicists call this the heat death. The point where entropy reaches its maximum and nothing more can happen. It sounds bleak, but it is also deeply calm. After an eternity of creation and transformation, the cosmos would finally be still. Every reaction would have ended, every imbalance resolved. Energy would remain, spread thin across infinity, like a soft, eternal glow. It is not the end of existence. It is the end of difference. The moment when everything becomes one. Even black holes, the last strongholds of matter, will not escape. Through Hawking radiation, they will evaporate slowly, releasing faint energy back into the void. First the small ones, then the large, until the final giant, perhaps one at the center of a galaxy, disappears with a whisper. That final release will mark the end of structure, the end of form, the end of contrast. What remains after that is hard to describe. There will be no stars, no planets, no light, no sound. Space will still exist, and so will time, but they will have no purpose, because there will be nothing left to move or change. The universe will be vast beyond comprehension, and yet utterly empty. The quiet after the last note of a cosmic symphony. And yet, even this is not truly the end, because the universe is governed by possibility, and possibility never disappears. Quantum physics tells us that even in the deepest vacuum, energy can fluctuate. Particles can appear and vanish in the blink of eternity. Perhaps, in that infinite stillness, new sparks of energy might emerge. Perhaps in one of those flickers, a new beginning could form, a rebirth of time, a second creation, another universe rising from the ashes of the old. If the Big Bang was one such spark, why should there not be others? Why should existence end only once? Maybe this long silence is not death but incubation, the deep breath before the next expansion. So as you listen now, let the thoughts settle like starlight fading in slow motion. Everything changes, everything ends, but nothing is ever truly lost. You are made of particles that were born in stars, that will one day fade, that may one day rise again in another form, another sky, another time. The death of matter is not the end of being. It is simply the return of everything to its origin. Pure potential. Close your eyes. The atoms that make you once burned in suns. One day, they will rest in silence. And someday after that, they might awaken again, in light. When all structure has faded and even matter has melted into light, the universe may not be finished. Beneath the silence of eternity, quantum physics whispers that nothing is never truly empty. Even in the darkest vacuum, energy flickers. Particles appear and vanish, dancing between existence and nothingness like sparks that refuse to die. In that quiet future, these fluctuations will still happen, tiny, random, eternal. And from one of those ripples, something astonishing could occur. A new explosion of space, a new expansion, a new universe. Physicists call this the quantum foam, the restless, bubbling texture of space-time itself. It means that even when the universe reaches perfect stillness, the seeds of creation are already there. One fluctuation could inflate, expanding faster than light, creating a new cosmos, a fresh Big Bang rising from the ashes of the last. If so, our universe is just one wave in an infinite ocean of creation. Some call this the multiverse. Each universe, born from the death of another, expands, cools, fades, and passes its energy onward in endless succession. There could be universes with different laws of physics, different colors of light, different forms of life, or none at all. And somewhere among them, ours still glows faintly, a spark in the cosmic sea. Maybe this cycle has happened forever. Maybe there was never a true beginning, only transformation, an infinite pattern of birth, silence, and rebirth. The Big Bang was not the first note of the symphony, only the most recent. And when our universe ends, its echo may become the opening chord of another. In that way, nothing is ever truly lost. Energy becomes form, form becomes energy, again and again, like a heartbeat that never stops. The silence at the end of time may only be the pause between one breath and the next. So when you think of the universe ending, imagine not a wall, but a doorway. Behind it, new light is already forming. New stars are waiting to ignite. New minds are waiting to open their eyes and wonder where they came from. Perhaps, in some far-off age, they too will look into their night sky, measure the fading light, and ask the same question you asked tonight. Is the universe coming to an end? And perhaps, somewhere beyond comprehension, the answer will whisper back, not yet. Time is something we take for granted, a steady river flowing from past to future, carrying everything along. But what happens when that river dries up? What becomes of time when nothing is left to change? When every atom is still? When motion and energy and life are gone? In the distant future, long after the last particle has decayed and the final black hole has vanished, the universe will enter an age beyond comprehension, an era of stillness. Physicists call it the eternal now, the moment when entropy reaches its absolute maximum and time, as we know it, stops making sense. Time is not an independent thing. It is a measure of change. A clock ticks because gears move, because energy flows. An atom vibrates, a planet spins, a star burns. All these motions are the rhythm of time itself. But in a universe of perfect equilibrium, where nothing moves and no energy flows, there is nothing left to measure. The arrow of time which began with the Big Bang finally disappears. Imagine the universe then, vast, dark, completely motionless. No stars, no planets, no sound, no light. Everywhere, the same temperature. Everywhere, the same silence. The cosmic story has reached its final page. And yet that page doesn't turn, because time itself has stopped turning. In this ultimate stillness, even words like before and after lose meaning. There is no later when nothing can happen. There is only existence, a frozen eternity, a forever that is neither beginning nor end. NASA's telescopes, if they could somehow persist into that far future, would find nothing to observe. No redshift, no light, no cosmic microwave background. The universe would appear featureless, as if erased. But hidden in that emptiness, in the quantum foam of space-time, energy would still hum faintly, the smallest possible fluctuations, the softest breath of what was once creation. Time itself might still flicker there, in quantum whispers. Short, spontaneous pulses of reality emerging and vanishing again. These pulses could last trillion years apart, too faint for anything conscious to notice. And yet, they might hold the key to eternity. A pattern of awakening, sleeping, and awakening again, each one giving birth to something new. If the laws of physics remain as we understand them, the passage of time depends on entropy, the measure of disorder. At the beginning of the universe, entropy was low. Energy was concentrated, hot, and creative. That imbalance drove everything: stars, galaxies, evolution, thought. But as entropy increased, energy spread, motion slowed, and difference faded. When entropy reaches its final limit, when everything is perfectly uniform, time loses its direction. It doesn't stop abruptly. It fades, dissolving like mist under sunlight. It's strange to think of the end of time not as destruction, but as balance. A universe with no difference between moments. A cosmic meditation. An infinite pause. All creation becomes a single, still note, held forever. And maybe that note is not silence at all. Maybe, if we could somehow perceive it, it would sound like harmony, the resonance of everything that ever existed vibrating in perfect unity. Every heartbeat, every star, every breath that ever was, merged into a single timeless presence. What would it mean to exist in such a moment? Would awareness itself fade away? Or would it expand beyond sequence, perceiving all of history, all possibility, all existence at once? Perhaps in that last instant of the universe, time folds inward, and everything that has ever happened becomes simultaneous. Every light, every thought, every birth and death, all happening together, forever. Some physicists imagine this final instant as a cosmic horizon, the edge of time, where the universe becomes timeless. To cross that horizon would not be to move forward, but to dissolve into the fabric of everything. The observer and the observed would become one. You would not be in the universe. You would be the universe. The final act of existence would be unity, the return of separation to wholeness. And maybe, just maybe, that's what eternity truly means. Not endless time, but freedom from time. Not a line stretching forever, but a circle closing perfectly upon itself. When the universe becomes still, it may finally understand itself. The silence might not be emptiness, but peace, the moment when creation, having explored every possible path, finally comes home. So as you rest now, imagine the slowing of that cosmic clock. Each second becomes longer, each heartbeat quieter, until finally, there is no division between moments. There is only the endless now, calm, luminous, eternal. The end of time is not to be feared. It is simply the universe coming to rest. And maybe in that rest lies the seed of everything yet to come. And so after billions upon billions of years, after every galaxy has burned its last light and every atom has released its final whisper of energy, the universe enters its deepest silence. This is not destruction, it is peace. The peace that comes not from ending, but from completion. There is no chaos left to calm, no heat left to cool, no star left to burn. The last photon has stretched beyond sight. The final vibration has gone still. Space has become infinite, yet completely uniform. A sea without waves, a sky without color. The cosmos has fulfilled its purpose, to expand, to evolve, to create, to return. If you could stand within this eternity, there would be no sound, no motion, no difference between here and there. The boundaries that once divided galaxies, light and thought, would dissolve. Everything would be one, not in proximity, but in stillness. It would feel like a breath held forever. This is the final sleep of the cosmos, a rest so complete that even time has forgotten how to move. No memory, no longing, no decay, only the perfect quiet of existence, balanced upon itself. Entropy has reached its end, equilibrium has been achieved, and the universe at last is whole. It is not an ending to mourn. In this stillness, there is beauty. The same beauty that was in the first spark of creation, the same grace that shaped galaxies and gave birth to life. All that ever was, the fire of stars, the rhythm of hearts, the pulse of thought, still exists here, but diffused into harmony. The energy is the same, only its form has changed. Every light that ever shone, every world that ever spun, every dream that was ever dreamt, they have not vanished. They have returned to the fabric of everything. The universe remembers, not through motion, but through being. This is eternity not as a stretch of endless time, but as a single perfect presence. And within that stillness, perhaps something else remains. Awareness. Maybe not as you know it, not as thought or memory, but as pure perception, quiet and infinite. It has no name, no beginning, no end. It simply is. It watches, it rests, it dreams. It has been called by many names: consciousness, creation, the soul of the cosmos. But it does not call itself anything. It simply exists, everywhere and nowhere, beyond need and beyond form. When physicists speak of quantum fields that never truly disappear, they may be describing this: the persistent hum beneath silence, the faint vibration that ensures nothing is ever truly gone. Even in the calmest sea, there is motion too small to see. Even in the stillest night, there is light too faint to perceive. The universe, in its deepest rest, still holds the potential to awaken again. Maybe this is how everything begins, not with a bang, but with a breath. A spark rising out of stillness, a single pulse of energy that grows, expands, and becomes something new. In that sense, this final sleep is not death. It is dreaming. And every dream, no matter how long it lasts, eventually gives way to awakening. Perhaps one day, far beyond imagination, the silence will tremble. One small fluctuation in the void will ignite a ripple in the endless calm. And from that ripple, a universe will bloom once more. Time will flow. Light will return. And new eyes will open to gaze at new stars. They will not remember this universe, but they will carry its essence. The same energy, the same laws, the same quiet longing to know itself. In that sense, nothing truly ends. The universe only changes form, breathing in, breathing out, forever. So now, as you lie here, feel that same peace within you. The atoms that make you were forged in dying stars, carried through galaxies, woven into the brief, luminous pattern that is your life. When you sleep, you return to that stillness. The same silence that will one day fill the cosmos. You are not separate from the universe's rest. You are part of it. Every heartbeat echoes the pulse of creation. Every breath is a rhythm of expansion and return. And one day, when all things rest, you will rest too. Not in darkness, but in peace. Not in ending, but in belonging. Because you were never outside of the universe. You are the universe, folded into thought, into time, into light. And when the universe closes its eyes, so do you. The stars have gone to sleep. The galaxies have exhaled. The music has faded into a single note that never ends. And that note is serenity, infinite, gentle, eternal. So sleep now, traveler. The cosmos is at peace. Its story is complete. And for this moment, this perfect, endless moment, all is well. Good night, child of starlight. You are home. The story has come full circle. From the first spark of light to the final breath of silence, the universe has lived its entire life. Vast, brilliant, patient, and beautiful beyond word. And now, in its endless calm, it drifts into the peace it has always carried within. There are no stars left to shine, no galaxies left to spin, no time left to count. The great cosmic ocean is still. The waves have faded. The song that once filled eternity now hums softly beneath the surface of all things, like a memory of music after the sound has gone. This is not the end. It is the return. Every atom that ever was, every photon that ever danced, every spark of life that ever dreamed, they have all come home. The universe, once wide awake, now sleeps. And in that sleep, it remembers everything. Perhaps, in that infinite rest, it dreams again. Not of what was lost, but of what could be, of light reborn, of stars newly kindled, of consciousness discovering itself once more. Because in the deepest silence, there is always the possibility of a beginning. The seed of tomorrow is hidden inside the calm of today. You are part of that seed. The atoms that form you were born in the hearts of ancient stars, carried through supernovae, scattered across space, and gathered into the shape you now call yourself. You are not separate from the universe's journey. You are its continuation. The cosmos sees itself through your eyes, breathes through your lungs, and wonders about its own existence through your mind. And one day, when your story pauses, your atoms will return to that great stillness too, waiting for the next dream to begin. So as you listen now, as your thoughts slow and your body softens, imagine the vastness around you, endless, peaceful, embracing. You are floating in the same calm that holds galaxies, the same quiet that will cradle the universe in its final hour. There is nothing to fear here. There is no end, only transformation. Close your eyes and feel the quiet spread through you. The quiet that once filled the void before the first dawn. The quiet that will one day welcome the last light. This is eternity. Not a stretch of endless time, but a single, infinite moment of being. You exist within it, and it within you. The stars that once burned now rest in your pulse. The galaxies that once collided now drift as memories in your breath. And the universe that once blazed with light now whispers softly, through you, to itself. All is calm. All is complete. All is one. Good night, traveler of starlight. Sleep deeply in the cradle of infinity. You have walked through creation, through fire and silence, through birth and ending. Now at the edge of time, rest. The universe is with you, in every breath, in every dream, in every moment of stillness. And when the next dawn comes, whether in this cosmos or another, you will rise again with it. New light, new stars, new beginnings written in the dust of old dreams. So sleep now, dear listener. Sleep gently. The stars have gone quiet, but their memory lives in you. You are the echo of the universe remembering itself. And somewhere, beyond the horizon of time, the first light of a new creation is already forming. It glows faintly, silently, waiting for you to awaken again. Good night, universe. Good night, to dreamer. Good night.